The centripetal force. The force that isn't really a force. Centripetal force, let's call it Fc, is what keeps a roller coaster car on the track when the car is inside a loop. It is what keeps the Earth in orbit around the Sun. But the most interesting part of the centripetal force is that it isn't really a force. It's the resultant of several different forces. As illustrated in the picture in front of you, the green vector is pushing the car towards the roller coaster track, while the red vector is pushing the car towards the center of the loop. This is obviously not true, seeing as nothing is pushing the roller coaster car in that direction. The hypothesis for this laboratory experiment is that the value of Fc would be within the interquartile range. In other words, the standard deviation would be less than 0.645 sigma away from the expected value. Several different materials were used for this laboratory experiment, and those were a string, weights, scissors, a ruler, a time measuring device, in this scenario a clock, a stationary metal construction, a cylinder, and dynamometers. Weights were first measured by using the dynamometers, which were put on the stationary metal construction. The immobile object's weight times the acceleration of gravity would be equal to the value of Fc. Two weights were then put on each end of the string. The string was threaded through the cylinder, and then one of the weights were rotated around the cylinder's axis 50 times. The technician would then stop the moving object and measure the length of the string. As presented in the picture in front of you, the mobile object, mobile weight, is rotating around the cylinder's axis, and the center of this circular trajectory is the cylinder. The immobile object times acceleration of gravity is equal to the centripetal force Fc. The results were that the value of Fc was about 1 sigma away from the expected value. As presented in front of you, this means that the value was not within the interquartile range, thus proving the hypothesis wrong. And why is this? For starters, the method had way too many errors. Two of the big errors were the technician's thumb and that it did not have a 90-degree angle. The technician's thumb was the fact that the technician had to stop the string using his thumb. This made the length of the string significantly larger, thus making Fc significantly larger. And the fact that it did not have a 90-degree angle resulted in the length of the string becoming once again significantly larger. As presented to your right, the length of y, which was the actual length of the string, is not proportional to the length of r, which was the expected length of the string, thus once again proving that the length of the string was significantly larger than expected.